we were on this part, right? This was the one.
Yes, ma'am.
So like first, let me show you the part. This is the acceleration time graph of the lift. So like since the acceleration is 0, so whenever the acceleration is 0, that is the body is like moving on stationary or it's not moving in at all, right? So in
Yes.
that case, you're gonna draw the graph like this. Let's say this is your x and y axis, right? Since velocity is uniform, there would be no change in velocity. So the graph would go this way. And probably the total graph would look like, let me show you. Firstly, when the velocity is uniform, it will go like this. Then for acceleration as 0, it's going to go like this. And for retardation, like going back to the starting point, it's going to go like this in the form of a trapezium, right?
Yes, ma'am.
Please tell me if there is any problem.
No, ma'am. No problem here. Okay.
Let's see if we have some more questions. Okay.
Okay.
This is like, okay, so these are your solutions. Can you see that? Now the graphs looks exactly like how we have discussed, right? So
Yes, ma'am.
T we got as 8 seconds, right? And from the equation, this, okay. So another question, I think this is your another question. Yes, this is your another question. So it's a long question. Yes, yes.
Oh, ma'am, before we continue with this, can you please go back to the previous slide so I can screenshot it?
Yes, please. Just a second.
Thank you.
This one, please go for that.
Thank you. Okay, ma'am. Noted.
This one. Please do one thing. Please have a full question with you, because when you do the solution, you do not have any idea like for which question we have solved, right?
Yes, ma'am.
So please copy the question first. Yeah. Hi, Nyasha. Is that correct? Like I'm taking your name. Is the pronunciation correct for the name? Nyasha, am I like audible? Okay.
Ma'am?
Yes, yes, Manya.
Ma'am, okay, so for the graphs example 1, right? Remember we did A together, right? And you just sketched out what B should be like in a trapezium. So should I draw the trapezium in my notebook now and then continue with graph example 2?
Just continue with your like graph example, like this second example. Like for first you have already took the screenshot, right? So please go for the
Yes,
second
yes.
one.
Okay.
Yes, Nyasha, am I audible?
Which topic we are doing? Which topic? Hello, ma'am.
Hi.
I'm fine. Which topic we are doing?
Okay. So like before going on to that, Please tell me, like, can you see the screen?
Yes, I'm
Okay.
seeing the screen.
Okay. That's great. Now, okay, Anyasha, like, it's the correct how I'm gonna pronounce your name. What's your name exactly?
My name is Nyasha.
Nyasha. Okay, that's great. So,
Yeah.
Nyasha, like, we are like currently in this batch, we are going on with the kinematics, right? So,
Okay.
yes. So, before like proceeding further in your case, let's do one thing. Let's write down the name of the topics that you have. Like, just give me an idea of what are the topics that you have done in your school in physics.
I've already covered kinematics.
Okay, you have already covered kinematics. That's great. And like, can you please give me a list of chapters which are like still remaining for you to complete in your school?
Forces.
Forces. Okay, and
Circular motion.
okay, just a second. I'll like check with the topics as well. So, are you talking about forces? The forces, force density, and pressure.
Yes, ma'am.
Okay. And okay, Nyasha. Then apart from that, what is the second chapter that you said?
Waves.
Sorry.
Oscillations in waves.
Like your voice is like it's fluctuating, like it's cracky. It's cracky. Can you please repeat what you said?
I'm saying oscillations in waves.
Okay. So I'm gonna like let's do one thing, Nyasha. I'm gonna take the name of the chapters, okay? You just tell me if they are done or not, okay? So first chapter, the physical quantities and units. Is that done?
Yeah, it was done.
Okay. Kinematics,
Done.
dynamics,
And then there's this topic, projectile motion.
dynamics. Projectile motion is in your
Projectile
kinematics. Dynamics has momentum,
motion.
Newton's laws of motion, non-uniform motion, linear momentum.
Yeah,
You did that?
dynamics. Yeah, it's done.
Okay.
Yes.
And apart from that,
conservation of momentum.
okay. Apart from that, work energy and power.
Working engine power is it's not yet done.
You have already done. Okay. Deformation of solids.
Oh, deformation of solids is done.
Okay. Waves.
What?
Waves. Like
Can
progressive
you come again?
waves, Doppler's effect, waves. WAVES, waves.
It was not yet done.
It was not done. Okay. Electricity.
Yeah. Electricity, it was not
Okay.
done.
Electricity is also not done. What about DC circuits?
GC
I
circuits
think
not done.
yes, probably yes. I think that because it's like related with electricity only. What about particle physics?
Particle physics is not yet done.
Okay, so this was like AS level. Now, since A level is combined of AS and A level, so about AS level, I have like asked from you. Now, tell me about A level. Motion in a circle. Have you done?
What are you saying? Can you come again?
Motion in a circle.
Motion.
Yes.
It was done.
Okay. Wasn't done? Like it's not done. It's not done, right?
Yes, it's not done.
Okay. And okay. What about gravitational fields?
Gravitational field, it's not done.
Okay, okay. Temperature?
Temperature, it was done.
Okay, it was done. Okay. Ideal gases?
Ideal gases, they are done.
Okay. Thermodynamics?
What?
Thermodynamics. Thermodynamics.
Can you come again, ma'am?
Yes, yes, yes. Like if it's fine, I like
It was
write
not
on.
done.
Yes, yes. I'll write the topic so that. Okay, so I'm gonna write the topics here. So I was talking about thermodynamics.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grade 6 to IGCSE, AS, and A-level. Start learning with us today.
And after that, I was talking about oscillations. Like these are the topics. Now, please tell me if these three topics are done in your school or not.
Electric field, they are not done.
They are not done. Okay. Okay, okay. And then what about, okay, next is capacitance.
Capacitance, it was not done.
Okay. Now, last only few topics are left, like magnetic fields, alternating currents, quantum physics. They are also not done.
Electricity and magnetism was done. Then AC current was done. But modern physics is not yet done.
Nuclear physics, okay. Like quantum physics, nuclear
It's not
physics,
yet done.
and medical physics as well.
Yeah. Yeah,
So,
they are not
okay,
done.
okay, okay, okay. So that's great. Now I have all information about you, Nyasha. So basically, like this information is required, like it's very much important so that we can go for alignment of the topics, right? Vanya, yes,
Okay, ma'am.
yes, please.
Ma'am, I had a question. Since I'm only doing AS level, like during our lessons, can you let me know which topics I only need to learn as well? Because I'm only doing AS, not A level. And also, I don't really go to a school, so this is the only school I'm at. So I have to learn from scratch from AS level. So I haven't covered any of the topics. So from the whole of AS.
No problem, Vanya. Like I'll
Yes.
tell you about the topics which are in your AS levels, and
Thanks.
like I'll also send you a list for AS level topics so that it's fine for you, right?
Yes, thanks, ma'am. Like a scope would help as well, and also, I also had another question.
Yes.
Since we are having a test on Friday, can I also have like a little scope on what to focus on as well, just so that I have like guidance for that?
Yes, yes, yes. I'll like do that. Don't worry. I'll do that. What is the
Thank you.
chapter? Like I said the test for. I didn't remember. Can you please tell me?
Oh, you mean our previous test, ma'am?
Basically the test that we're gonna have. We're gonna do any test on this Friday.
Yes, ma'am. I'm not really sure. I just know that we did work, energy, and power previously.
Yes, yes, yes.
No, I'm not sure about what's coming in the next test.
Like I remember a little bit. I told you about some test, but I exactly like do not remember what was the topic. Okay, no worries at all. We'll see. We'll look into that. Okay, so now someone new is here. Brandon, hi. Hi, Brandon. Please tell me, like, if you can hear my voice and like I'm clearly audible and visible to you? Can you please try unmuting yourself? Like just a second, everybody. Can you hear me, Brandon? Okay, so maybe he's having some network problems. Now, see everybody, like Nyasha, for like this batch, we have like completed your magnetic field as a topic. Don't need to worry about that. I'll be also sharing the notes for the chapters that we have completed previously. Apart from that, we have completed work, power, and energy in this batch. Okay. And now, like, we are going on with kinematics. We have like started with kinematics, and we have also completed a lots of part on kinematics till your graphs, right? So,
Okay, you can continue with kinematics.
okay. So would it be fine, like, if we go on for kinematics, like the remaining part that is for us, like after this your graphical part, we have to go for like equations of motion as well and questions related to that, right? So since like
Okay,
there is
yeah.
lots and lots of numerical part in kinematics, so that's going to help you out as well. Like I have lots and lots of questions based on, especially on equations of motion. So they are like so good that it could be a 1 hour of practice session on that, and it's really good. So I think that would be helping you out as well. Now, so let's begin with motion graphs now. So Vanya, let's do one thing. The question that you were doing previously, take a screenshot for that and do that question in your homework. We'll begin for this part, your coming
Okay,
part.
ma'am.
Okay. So I'm gonna like,
I've
yes,
taken a
yes.
screenshot of it.
You have already taken a screenshot?
Yes, ma'am.
Okay, that's great. So now, like in this kinematics chapter, we have completed the first main concept, which is your motion graphs. And now we are going on to something new, which is your formulas for constant acceleration. Now, this is specifically where your acceleration is going to be constant. It's not going to change. So these are your most important equations. Yes, Vanya?
Ma'am, I don't think, have we covered this? I don't think we have, though.
Okay. So let's like brush up and let's quickly move. So see, now if a particle is moving in a straight line with a constant acceleration, so what's going to happen? There are 5 equations of motion, basically uniform motion. These equations are for uniform motion. So these are like
Acceleration.
okay, yes. So sorry. So you're going to use these equations according to the situation that is given by the numerical. Right, everybody? And these are very, very important. Can you do one thing, everybody? Please quickly turn on your cameras, everyone. Yes, Brandon, can you please hear me? Please tell me if I'm audible or not.
Yes, you're audible.
Okay, that's good. Great, really nice. So, like, Brandon, let's have a discussion with you as well. Like, this is your first session, so we have to do that. That's necessary. So, everyone, please give me like the next 5 minutes too. So, Brandon, can you please like tell me what's going on in your school, specifically in physics? Yes.
We've covered
Brandon, your voice is breaking.
the
Your voice is still breaking.
now doing frictional force.
Brandon, your voice was like really breaking. I like could not hear anything. It's okay. Okay, yes, Nyasha, one more thing I forgot to ask you from. Can you please tell me about your coming mock test and your like coming exams? When are they gonna happen?
At the end of this month.
Nyasha, your voice is also breaking. Vanya, just
At
can
the
you
end
unmute?
of this month.
Yes. Is my voice clearly audible to all of you?
Yes, ma'am.
Okay, now it's fine. Yes, Nyasha, can you please repeat what you said?
I'm saying at the end of this month.
At the end of this month are your mocks, right?
Yes, I have an exam.
Okay. So now, like, do you remember, like, are all of the chapters gonna come in your mock exams or any specific topics?
I think kinematics,
Kinematics is gonna come,
dynamics,
right? Okay.
dynamics,
Okay.
dynamics,
Yes. I can hear that. And
work energy and power.
work energy and power.
Work energy and power.
Yes. Any other chapter?
Any oscillations and waves. Yeah.
Sorry. Force density and pressure.
I think it's gonna come.
Okay. So now, okay, that's fine. Any information about the final exams also, Nyasha?
I don't have any information.
Okay. Now, Brandon, coming on to you, can you do the same thing? Just describe me. Like, first, please go for your coming mock exams and your final exams. What are the topics that are gonna be there? Can you please let me know about that?
Kinematics.
Yes. Okay. Can you please tell me the tentative date on which the mock exams are gonna happen?
I think in 3 weeks time.
Okay, in 3 weeks. Now, please, can you tell me the
Yes, ma'am.
topics that are gonna be there in your mocks?
There's going to be kinematics,
Okay.
accelerated motion,
Accelerated motion,
dynamics,
dynamics. Okay.
forces,
Forces,
work, energy,
like
and
force
power.
density and pressure. Okay.
Yes, ma'am.
Okay.
Work, energy,
Yes.
and power.
Yes. Okay.
Momentum,
Momentum.
matter and materials,
Okay.
and also waves.
Waves. Wait, that's a long part.
Yes.
Okay. And
Yes.
what about like final exams? Any tentative date for that as well?
I'm not yet sure. It hasn't been given.
Like probably what I think it's gonna be October, November for everyone, right?
Yes, ma'am. Yes, ma'am. Final exam is October, November.
Okay. That's great. Really nice. Okay. So Like also give me like a very little bit information about like what are the topics, like all the topics that you told me about mock exams, are they done in your school?
Yes, ma'am.
Okay. And what are the topics that are left in your school?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Yes. Maybe there is some network problem by your side. So no problem, Brandon. See, you can do one thing. Like once the session gets over, you can make a list and share that in your group, right?
Just to go and check
Yes,
my
like there is so much of network problem. Like today's session is specifically based on for the topics discussion only. So probably like coming on to the track would be from the next session. So like let's see what can we cover. Like we only have like 5 to 10 minutes more. So let's see how much we can do. So these are your important formulas basically that are being used in case of like constant acceleration part. So these are your equations. Please see that. Brandon, don't worry. Like, I guess there is some network problem by your side. So you can do one thing. You can prepare a list of the topics that are not covered. Okay. Seems like so much of network problem is there. Okay. So, like these are your equations. Now let's talk about the terms that are in your equations. So when we like talk about, okay, let's go for this for any one of you. Vanya, please tell me what does the V means in the equations? What does V denotes?
Final velocity.
Final velocity, exactly. So here, like any object, let's say starts from A point, that is from rest, and like goes to like covers till the speed of let's say 30 meters per second. So in that case, the velocity with which it's covering the final like the final point, the velocity that it has at the final point is gonna be its final velocity, and that would be like denoted with V. So V is final velocity, U is initial velocity at this point. So like initially at the starting point, so that is your initial velocity. T is your time period. And A is your acceleration, right? Is that fine, Vanya, Nyasha,
Yes.
Brandon? Like, it's the first session is gonna create a little bit problem. It's gonna create a little bit chaos. Like, since you're doing chapter from like, it's not from very beginning. So don't worry, when you like go for like 2-3 more sessions, things are gonna be on track. Don't worry about that. And S is gonna be the distance. And like it can be the distance, also it can be said that it is the height. Right, everyone? So
Yes, ma'am.
Yes, ma'am.
that's great. That's really nice. Please read this out, everybody, and please tell me if there is any confusion in any of the equations. Because this is the base, we are going to use these equations in the numerical part. In like kinematics is probably based, like the main part for kinematics is the numericals. Specifically, the most important numericals are your graphical numericals as well as your numericals based on the equations. So this is like very, very important. Please tell me if things are fine till here.
Yes, ma'am.
Okay. Just a second. So these are the terms like used with the, like denoted with their SI units as well. So for vertical motion, acceleration due to gravity is 9.8. So probably whenever you are like any object is falling down towards the ground, or like you throw that upwards, that's going to be its vertical motion. So if the vertical motion is done on the earth, specifically the acceleration due to gravity would be a constant and denoted with small g, and the value for small g would be 9.8 meter per second square. Is that clear, everybody?
Yes.
Yes, ma'am.
What about you, Nyasha and Brandon? Okay. Okay. Let's go a little
Clear.
bit slow.
Yes, ma'am. It's clear.
Let's skip this part for here. I think we have done this one year, right?
No, not this, ma'am. We didn't do that.
Okay. Specifically, just a second, I think the derivation part is not equations are there, but let's see if derivation part is there, then we'll go for that. Otherwise, we'll go for the numerical part. So probably no, the derivation part is not a part for your syllabus. So we'll directly go to the numerical part. Okay. So let's go for an example. Please see this example and try this, everybody. Yes, Swanya.
Ma'am, I just wanted to know, is this for AS level or A level?
Yes, AS level. It's for AS level.
Okay.
The whole kinematics is for AS level, Vanya. Like all of the initial topics are for AS level, whether it's force, density, and pressure, your kinematics, dynamics, and work energy and power that you have done. Everything is in AS level, right? So do not worry about that. Rest, I'll send you the topics. Don't worry. So everybody, please see the question. Take some time, and probably like this is gonna be our last part for today's session. We'll not be moving forward towards anything. And in the next coming session, I have a separate slides specifically based on the numericals for your kinematics. I think projectile part is left. We'll go for that. And apart from that, I think nothing is left with us. Don't worry, I'll share you the notes for kinematics, Nyasha and Brandon. One year for you also, I'll send that. So just read that notes so that you are like not coming without any pre-knowledge for the chapter. So just go through the notes. And in case if you find any confusion in any topic, please do let me know in the next session. Right, Nyasha, Brandon?
Yes, ma'am.
Okay, ma'am.
Yes. Okay, then please like look at the question, see if you can do that or not. This is going to be the last question for our today's session. So taking your attendance, everybody, just a second. Let's do one thing, everybody. Take a screenshot for this question and try to solve it in your homework. Right? Everyone?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. And like, please do go through all the things that that from the notes that I'll be sharing, and like do that. And in case any problem is there, please do let me know in the next session.
Yes, ma'am.
Yes. So please let me know once you all are done taking the screenshot.
Yeah, we are
Done,
done.
ma'am.
Okay.
Well done.
Okay, that's great. So let's do one thing with that. Let's wrap up our today's part here only. And let's meet again in our next section, like freshly with some very fresh numericals, and we'll take something from the initial part only. Everything we'll go for initial part with the like starting part. So please do have a pre-knowledge for the kinematics part that we have done.